So today what we're going to be doing is we're going to be talking about 4 different things. The first 2, empirical and molecular formulas. We'll also be discussing density. We'll be discussing volume and mass ratios. This is all not too bad at all. So the first one we're going to talk about is empirical formulas. So, empirical formula. This is pretty easy. It's the lowest whole number ratio that a formula can have. So the lowest whole number ratio. So let's take an example. So if we look at C6H12O6, which is glucose, the question is that an empirical formula? Well, is it the lowest whole number ratio? No, it's not. So this is not an empirical formula. This is called a molecular formula. A molecular formula is simply a multiple of the empirical. So let's find the empirical formula. So each one of these numbers can be divided by 6. So the empirical formula for C6H12O6 would be this: CH2O. CH2O. That's the empirical, that's the molecular. Now, the other thing is, if this is called the empirical formula, then what must the empirical mass be? Well, you just add them up. So we have 16 and 12, so that's 28, 29, 30. So the empirical mass, EMP mass, 12 and 16, that's 28, 29, 30, 30 grams. Now, this is very interesting. So if the empirical mass is 30 grams and the molecular formula is a multiple of the empirical, well then the molecular mass must be a multiple of the empirical mass. So all I have to do is, well, this is 6 times more than that. So what we do is 6 times 30. So this molecular mass must be equal to 6 times 30 or 180 grams. So once again, we'll go over this more in just a minute. The empirical formula is the lowest whole number ratio. The molecular formula is a multiple of the empirical. The empirical mass just means you add up the empirical mass and you get that. The molecular mass is a multiple of the empirical mass. So I divided this by 6 to get the empirical formula. So in order to get the molecular mass, I multiply that by 6, get 180. But like I said, we'll go over this right now. Question is that an empirical formula? Well, the empirical formula is the lowest whole number ratio. That's a fraction. That's not a whole number. So we have to pump it up to a whole number. So how do I pump up a half? I double it. But if I double that, I got to double that. So the empirical formula of C1/2H would be CH2. And it would be the same for this. It was C.25H. How do I pump that up? I multiply that by 4. So this would be CH4. That would be the empirical formula. Not that, because that has a fraction. Okay? Everybody set with that stuff? All right. Now watch. CH2. That's an empirical formula. It's not a real formula because carbon has to have 4 bonds around it at all times. So there's really no such thing as CH2, but it's an empirical formula. So we're going to label this That's an empirical formula. Now, what's the empirical mass? The empirical mass is 12, 13, 14. So, empirical formula, empirical mass. Now, let's do a multiple of the empirical formula, which will be the molecular formula. So a multiple of CH2 would be C2H4. Now, C2H4 is no longer an empirical formula because it's not the lowest whole number ratio. So this is called a molecular formula. And now we're going to find the molecular mass. And remember what I said a couple minutes ago, the molecular mass is a multiple of the empirical mass. So, if the empirical mass is 14, and I just doubled it for the molecular formula, then we just double that. So that's 28 grams. And you can count it here, 12 and 12 are 24, and 4, that's 28 grams. Next. The next one out would be C3H6. And we know that that is a multiple of that, so that's a molecular formula. And the molecular mass is a multiple of that. So we just add 14 there, we doubled that, now we got to triple that. So now we triple that. So 28 plus 14 is 42. So that's how it works. Okay? So we know, we haven't written it down yet, but we know the molecular formula is a multiple of the empirical formula. That's how it's supposed to be. Now we've got a trick question that I have to go over, and then we'll go into how to find empirical formulas. This is huge in bonding, CH4. It's methane is the name of it, but it's a symmetrical molecule, so it's a nonpolar molecule with polar bonds, so it's real. So here's the problem. This is the lowest whole number ratio, but it's also a real substance, so CH4 very interesting. So CH4, since it's a real substance and it's the lowest whole number ratio, it can be both an empirical and a molecular formula. But we don't talk about this too much in high school chemistry. All right, so empirical formula, lowest whole number ratio. A molecular formula is the lowest, a multiple of the empirical formula. Now we're going to figure out how to find empirical formulas. Now, this is a little bit of a trick question. 50% of this empirical formula is sulfur and 50% is oxygen. And then a lot of my students go, oh, that's 50-50, then the empirical formula has to be SO. No, it's not, because sulfur and oxygen do not weigh the same. If they were weigh the same, if they were to weigh the same, then it would be just S and O. Now, a quick way to do it, watch. 2 steps. The first thing you have to do, divide the percent by the atomic mass of the element. So 50, sulfur weighs 32. Oxygen weighs 16. So 50 divided by 32 So 50 divided by 32 is 1.56. 50 divided by 16 is 3.1. So divide by the atomic mass and then divide by the lowest number. So I have 1.56, I got 3.1, the lowest number is 1.56. So 1.56 divided by 1.56 equals 1. 3.1 divided by 1.56 is 2. So the empirical formula is SO2. So that's how you figure out empirical formulas. We'll do another one, but divide by the atomic mass, divide by the lowest number, and you got it. Now here's one that has 3 elements in the empirical formula. Ca 40%, C 12, and O is 48%. So, rule, divide by atomic mass. Well, this one, atomic mass of calcium is 40, so that's 1. Atomic mass of carbon is 12, so that's 1. The atomic mass of oxygen is 16, so this is 3. Now, you divide by the lowest number. Well, the lowest number is 1. 1 divided by 1 is 1. 1 divided by 1 is 1. 3 divided by 1 is 3. So, this formula is CaCO3. So, finding empirical formulas from the percents, very, very easy. So that's how you do that one. Okay? All right. So now, watch. Okay, so the next thing we're going to do, remember, empirical formula, lowest whole number ratio. Molecular formula is a multiple. So to find the molecular mass, you can do it this way. So watch. So D equals M over V. So if I said this, the density of a gas is 1.96 grams per liter. All right? At STP, find the mass. Well, if it's at STP, we know that the volume on the bottom is 22.4. And we want to find that. We want to find the molecular mass. We simply multiply the density times the volume. And when we do that, we get 44. That would be the molecular mass of that gas. Okay? So that's density. Now I'm going to show you one more density because density's on this test, and a lot of people mess this up. So, it says find the volume of a gas if the density is 1.44 grams per liter and the mass is 72. This trips up students because the unknown is in the denominator. So, we have 1.44 grams per liter equals 72 grams over volume. And for some reason, students have a hard time trying to figure out how to get the unknown out of the denominator. Okay? So the quick way, you multiply both sides by V times V times V, and then this V cancels out, and then you slide, you want to get V by itself, so you slide the density underneath. So this would be 72 divided by 1.44. And that would come out to be 50 liters. So one more time, if the unknown is in the denominator, multiply both sides by it, cancel that out, and then get V by itself by dropping the density down underneath. A trick question. A lot of students get that wrong. Okay, the next thing we're going to do is find the molecular formula when I give you the empirical formula and the molecular mass. Okay? Okay, so watch. I want to find the molecular formula. And look what has been given. The empirical formula is CH3 and the molecular mass is 90. So what we have to do is, since we know that the molecular formula is a multiple of CH3, well then this 90 grams has to be a multiple of the empirical mass, like we've done before. So find the empirical mass. That's 12, 13, 14, 15. So the empirical mass is 15. The molecular mass is 90. So all I do is I take the 90 grams, that's the molecular mass, divide it by the empirical mass, which is 15. And we get 6. Now, what does that 6 mean? That means this, 6CH3. Or, when I blow that 6 through everything, that would be C6H18. And there is my molecular formula. So one more time, if they give you the empirical formula and the molecular mass, find the empirical mass and divide it into the molecular mass. 90 divided by 15. Okay, everybody understand that? We are going to do a big problem. This involves all three. All right, we're going to find the empirical formula, we're going to find the molecular mass, and then we're going to find the molecular formula. Okay, so like I said, this is a 3-step problem. On the test, it's going to be worth 15 points. So I give you the percents to find the empirical formula, which is number 1. Find the empirical formula. Those are the percents. The second thing I give you is I give you the density of the molecular formula at STP. So from that density, you can find the molecular mass. Once you find the molecular mass, you got it, because you take the molecular mass, and after you find the empirical formula, you take the empirical mass, divide it into the molecular mass, and you got that. So let's do it. So remember, to find empirical formulas, you divide by the atomic mass. So 30.4 divided by 14 equals, and 69.5 divided by 16 equals. Okay, so 30.4 divided by 14 is 2.17. 2.17. All right, 2.17. And then 69.5 divided by 16 is 4.3. So now we divide those two by the lowest, which is 2.17. So we divide 2.17. We get 1N. Put it up here. N. We get 1N. And when we divide 4.3 by 2.17, we get 2. So now we know it's NO2 is the empirical formula. So we're going to put that right here. Find empirical formula. It's NO2. Now, to find the molecular mass, I was giving you guys the density at STP. So what we do is this. We get 6.16 equals M over 22.4. So 6.16 equals M over 22.4. And when I multiply those two together, I get 138 grams. That's my molecular mass, 138 grams. Now, this is the best part. I've got the molecular mass, I got the empirical formula. Remember, you have to find the empirical mass and divide it into the molecular mass. So, O2 is 32 and N is 14. 32 and 14, that is 46. So the mass here is 46 grams. That's the empirical mass. So I just divide that into 138, and I come out with 3. So that's not the molecular formula, but it's going to be, because if NO2 is the empirical and I have 3 for the molecular formula, you simply go like this. 3 NO2, which equals N3O6. So that is a 3-step problem. Each question is going to be worth 5 points. This is a 15-pointer. So first you have to find the empirical formula, then the molecular mass, and then the molecular formula. Okay, so that's how you do empirical and molecular. Now, another couple easy things, volume and mass ratio. So let's take H2O volume ratio. You just look at the subscripts. 2 to 1. So the volume ratio you just look at. So this volume ratio would be 2 to 1. Let's do another one. CH4. CH4 would be 1 to 4. So you just look. NH3, that would be a 1 to 3 volume ratio. All right? Now, to do the mass ratios. So for the mass ratios, it's just what it sounds like. You have to find the mass and then knock it to lowest whole number ratio. So the mass of H is 1. There's 2 of them, so this is 2 to 16. But that's not the lowest whole number ratio. So the mass ratio of H2O is 1 to 8. And then we have this one. B would be CH4. So now CH4, that's 12 to 4. But that's not the lowest whole number ratio. So it would be 3 to 1. 3 to 1. Don't forget, for mass ratio, you have to find the mass and knock it down to lowest terms. For volume ratio, you just look. Okay? Everybody set with that? Those are 2 very, very easy things. So, we have gone over empirical formulas, molecular formulas, density. We've gone over volume ratios and mass ratios. Okay? The final thing we're going to go over is percent composition. And this is a pretty easy one. Okay? The formula is really easy. It's just part over whole times 100. So, I'm just going to do one of these problems, and it's going to be a difficult one. So, this is MgNO3 2.4H2O. Since this contains water, it's considered a hydrate. So, here's the question. Find the percent of water in that hydrate. So now what you have to do is we have to find the formula mass of that whole thing. So this is how we do it. Magnesium, this weighs 1 mole of magnesium, it weighs 24 grams. We have 2 moles of nitrogen, that's 28 grams. We have 6 moles of oxygen, and that's 96 grams. Now, that dot means water of hydration. So it doesn't mean multiply the masses times the water. It means add them. So plus, and the way I like to do it so you don't screw up, is water weighs 18, so it's plus 4 times 18. That's the easiest way to do that. Okay? So now we have figured out all the masses, and so all those masses add up to 220 grams. That's the molar mass of that whole thing. So this equals 220 grams. Now, that's the whole. Now remember, we want to find the percent of water. Well, water is 4H2O. So what we have to do is we have to put the amount of water over 220. 4 times 18 is 72. So we go like this. 72 grams divided by 220 grams times 100. All right, so we have 72 grams divided by 220 times 100, and that comes out to be 28%. So 28% of this entire substance is water. That's percent composition. Part over whole times 100. And you will definitely have one of these hydrates on the test. Okay?